Everyone, and welcome. Thank you all for joining us today for this Microsoft Reactor livestream event. My name is Erika, and I am the program manager at microsoftreactors.com. Before we begin, I'd like to quickly review two items, our code of conduct and the event guidelines. But before that, I would also kindly like to ask you to check in via the link above here and use the event ID 13986. Thank you for that. But yes, so here we are today, and today's session we are going to be talking about Altair on Azure Sphere, and this is a part of our July OT event. Yes, before we get into it, a quick word on our code of conduct. The key thing to take out here is to be respectful of other people's views, be understanding of differences, and be kind and considerate in the way you engage. And now just a few words about event guidelines. This event is being recorded, and your video will appear if your camera is on. The chat will be open throughout the session, and we do encourage you all to participate in it. If you need closed captioning, it is available for you. Just click on the CC or live captioning icon at the bottom of your screen. And now let's move on to the reason why we are here today. In today's session, we are joined by Dave Glover, who is a software developer at Microsoft. They will walk you through how you can bring to life the Altair on the Azure Sphere and have fun with Altair BASIC, C, and Assembler. This session will run for about 30 minutes with some time for questions at the end. But now let's welcome Dave. Hi, Dave. Thank you so much for joining us today and hosting this session in the July OT series. I think it's time for me to hand over the word to you. I will switch off my camera, but I'll be here in the background listening if I'm needed. Thank you.
Okay. That's great. Thank you very much. Really appreciate the intro. Welcome, everyone. My name is Dave Glover, and I am in a role called a Cloud Developer Advocate. And my role, and I have a particular focus on Internet of Things, and I'm based in Sydney, Australia. You can follow me on Twitter, so at @dglover, and I'm going to point you to an article, and probably the easiest way to get to it is if you just go and search for IoT Tech Community, and on the IoT Tech Community you'll find a blog item that I've put there, that you'll find more information on this project. And also down at the bottom there's a link off to GitHub. And on GitHub, you will find all the source code. So the applications, all open source. So I also, in fact, what I'm going to do is I'm going to pop out of here and go across to my browser. Okay, so what I've got here is I've just opened up the main article that I published, I think it was last week on the 15th. And it was this article titled up there called Bring New Life to the Altair 8080 on Azure Sphere. And you can see there goes the Azure Sphere device, which is on the right-hand side. I'll click on that, make it bigger. And next to it, we've got a front panel. Now, the front panel, you can also get, we've also got the hardware design for that. So you can download that and actually go and build your own front panel as well. Now, if you're not familiar with Azure Sphere, Azure Sphere is kind of made up of three components, made up of a cloud component, an operating system, and a certified microcontroller. And the thing that kind of makes Azure Sphere kind of unique is it's secure by default and secure by design. And what does that mean? That means that you don't have to worry about the security. You just focus on your application. And Azure Sphere really worries about all the security. You go and define what you want access to, and should you, and you can only access those resources that you've been defined, that you've allocated. That's kind of at a very high level. Now, if you're not familiar with the Altair was a computer that was kind of really the computer that kicked off the personal computer revolution, and it was introduced around about 1974. It was actually built on a second generation Intel CPU, which was the Intel 8080. And you can see down here, this was the a photo there of the original Altair. And the way you programmed it is you programmed it by flipping switches. And in fact, I'm just going to switch across to my device. And you'll see that this is the device here I've got here. And I'm going to show you how you can kind of program the device using those switches. So the idea is that you had an address bus. In fact, why don't I jump across to the device? So you'll see that the lights down here, these represent both the address bus as well as the data bus. And then depending on what mode you were in, you could go and basically program address locations or data locations. And that was kind of the approach to it. So when it first came out, it was super primitive, and you really you really programmed it at the machine code level. And what happened after that was that young Bill Gates and Paul Allen spotted an opportunity, and they thought they could do a BASIC for it. And they introduced Altair BASIC, and it was really the first Microsoft product that came out. So that was kind of a bit of a history of really the beginnings of Microsoft in some respects, are very closely tied to the original personal computer that came out. Okay, so I've shown you the device, so I've shown you the device. So the device is there in kind of three incarnations. Now, actually, before I get too much further, I just want to emphasize, if you do have any questions, please feel free to ask them in the Q&A down in the Teams view Q&A. Alrighty, so there are kind of three configurations you can do for the Altair running on Azure Sphere. And it kind of depends on your enthusiasm level. So if you're more of a maker and you're comfortable building out your own hardware, then I said before, we've got the hardware designed for the panel. And this panel is actually an iteration on an original design panel by a guy called Daniel Carling, who published his design there out as open source as well. And we've made a couple of alterations to it and also published it. For folk who want something a bit more off the shelf, then this is an example here. We've got the Azure Sphere. So this is an Azure Sphere built by Avnet. And you'll see on here, we've actually been, the board for this project was designed by Microelectronica. And they have designed what's called a click, an Altair click. So you'll see it's called the 8080 Retro Click. It's not quite available yet, but it will be very soon. And you can see the whole idea behind this. We've got LEDs and we've got 16 buttons on here. And those 16 buttons, they literally map across to the 16 buttons that are along on here. So it's just kind of the same principle. And you can get up and running with it. Now, if you want to play around with this today, that Micro also have we have another configuration supported for this, and this is with two existing panels from Microelectronica. They have a button click, a 4x4 button click, and an 8x8 LED panel. And I hope you get the general idea is that the devices there, you can kind of, the idea behind this, you get an off-the-shelf view or off-the-shelf ability to go and build this project without necessarily having to go build the whole front panel. And all the supported, you just go into the CMake file and you say, look, I want this configuration. So that's kind of the configuration options. Alrighty, so what I do is I recommend you just go search for IoT Tech Community, and that'll take you up to the Tech Community website. Go click on Internet of Things and scroll down through there and you'll see a few projects up there, and there goes the project. So that's a great launch point. So just go search for IoT Tech Community. Okay, so I said that the project is all open source and it is up on GitHub. And if you go searching for, in fact, it's github.com, Azure Sphere, cloud enabled Altair 8800, or just go search for it for that matter. And you'll see that there are basically 3 repos as part of this. There's the main project, which I'm going to talk about in a moment. There's the hardware definition that you can go and drop that down, and then you can go and build that build that environment. We've got an implementation of Wolf MQTT for the project. And we've also got the disks, and I'm going to explain a bit more about how that all hangs together. Okay, so that's the main repo, and where to go from there. If you go into the Azure Sphere Altair 8800 project, and there's an intro here, and that intro points off to the wiki. And if you're not familiar with this, if I just go to code view, and you can also just click on the wiki view. Alrighty, so the project is fully documented, and in fact it's going to go up into Microsoft Learn as a learning module. That's kind of where it's planning on going. And you'll see down here on the right hand side is a navigation through the whole project. So as I said, it really is blow by blow about how to go and configure this and run this yourself. There's a brief introduction there about Azure Sphere. So as I said before, Azure Sphere is secure by design and secure by default. And that's really its unique selling point into the market. It's obviously also a microcontroller. So it's made up of a microcontroller, cloud, an operating system, a Linux-based operating system, and a cloud service. And scroll down a bit through there, and you'll see an introduction to the project and a bit about the architecture. And I'm just going to explain a bit about the architecture now. In fact, if I open in a new tab, is that going to be a good thing or a bad thing to do? Okay, so this is the overall application architecture. Now, it's kind of like a three-tier architecture. I read someone describe this as a fairly traditional approach to IoT, and it is. Now, so one of there were kind of a number of goals behind this project. The first one was to kind of push the limits out of Azure Sphere and really try and see what we could do and figure out some interesting design patterns. And that's kind of the bigger goal of this. Now, the other goal was it's a kind of interesting retro project. And from a retro project perspective, it's a really interesting way of learning about how computers work. So you might really be familiar with that, but you might have members in your family, you might like to teach them about, I don't know, assembly or something along those lines. Anyway, so as I said before, it's like a fairly traditional or standard kind of architecture for an IoT application. So what we've got the Azure Sphere, which is a device, and that's running the Altair emulator. Now, the Altair emulator is an open source project. You'll find it on a number of different platforms. And what's been done is that someone has written an Intel 8080 emulator. So on the Azure Sphere, which is an ARM-based device, we're running an Intel 8080 emulator in software. Now, on top of that, oh, sorry, thank you. Someone just said, please, can I share my screen? Thank you. Thank you so very much. Apologies for that. Hopefully, I don't think I got too far. Thank you for doing that. Alrighty, in fact, let me just jump back. So I went over here. Remember, I was talking through, talking through the IoT Tech Community. Go search for the IoT Tech Community, and you will find this article up here about which introduces the project. So where I've got to now is just introducing the project up on GitHub. And so on GitHub, there is a project, there's a GitHub site called Azure Sphere Cloud Enabled Altair 8080. And you'll find 4 repos on there. One's the emulator. Second one there is the hardware design. The third one there is the Wolf MQTT library for communications. And the fourth, I should say, is the disks. In terms of documentation, if we go across to the Altair Azure Sphere on Altair 8080, and what I did is I went to the wiki, and down through there, I introduced the project. So thank you, apologies for not sharing the right screen. Okay, so in terms of the overall application architecture, as I mentioned before, one of the key parts of this is that we've got an emulator, an Intel 8080 emulator. The beauty of that, it's made up of about 70 to 80 instructions. So it's a really easy CPU to kind of get your head around. Now, on top of that, what we're doing is we're running the compiled binaries of Altair BASIC. Now, someone asked me on the blog, Did we have access to the source code? And no, we didn't have access to the source code for Altair BASIC. There was just a binary. And what we're doing, we're running the original binary on top of the emulator. So we can run Altair BASIC. Now, we're also running an operating system called CPM. Now, it depends on what age group you are. You may vaguely remember something called CPM. It's standard for something like Control Program Monitor. And it came out before DOS. So it really was around 1974, 1975. And on top of that, and again, we're running the binary of CPM 2.2, which was really the most popular version. And on top of that, we're running MBasic, so Microsoft Basic, which is again one of the first products from Microsoft. There's a C compiler and an assembler. And you can go and compile your own applications. So that's running on one of the cores on the Azure Sphere. Now the Azure Sphere has a number of three cores that you can go and deliver custom code onto. So we've got another core, which is what's called a Cortex M4 core, and on that I'm running a virtual disk cache. It's what's called a least recently used cache, and the idea behind this is we host the disk up in the cloud, and obviously makes for having a disk sector request going up to the cloud and back again is relatively slow relative to having a local disk on the system. So the cache is there to kind of speed that up. The middle tier, we've got a number of cloud services. We've got Azure IoT, and we're using that for reporting and configuration. We've got a static web app for the Altair web terminal, and I'm running a virtual machine. And in that virtual machine, I'm running a virtual disk server, and then I'm also running a Mosquito, what's called an MQTT broker. And then on the right-hand side, I'm using a web terminal. And the beauty of this is you can really access it from anywhere as long as you've got the right credentials. And just so you know how that hangs together, I'm using something called Xterm, which is providing a console. And I'm using MQTT.js, which is a JavaScript MQTT library. So that's kind of the overall architecture of the solution. So they're just scrolling back down through here. So what I'm going to do now is I'm going to I'm just going to pop across. So as I mentioned, down the right hand side, we've got all the documentation to go and build this. So what I'm going to do now is I'm going to switch across to the Altair terminal. And in fact, what I'm going to do is I'm going to restart the device. In fact, while that device is restarting, I'm just going to talk a bit more about the architecture. Okay, so what we've got here is this is the way that the terminal, so remember I've got a web-based terminal talking to an IoT device. And the way this works is that basically what I've done is I've redirected I/O for terminal, basically standard in, standard out through an MQTT client across the internet into the Mosquito browser and then back to my desktop. So it's kind of doing a round trip. So what I've done, just jumping back to the browser. So I'm just here in the browser and I've connected to my device. And my device is called Dave's AvNet device. And you can see that it's connected to an MQTT broker. And the way this would have started when you first had the Altair back in 1974, 1975, and you loaded up Altair BASIC on it, you would have been prompted for memory size. So I'll just come in here and put in 32K. You could have up to 64K address space, terminal width 80, and I don't want that. And I'm just going to load tic-tac-toe BASIC. No, I'm not. Tic-tac-toe. Alrighty. Okay, so that's loaded up a basic application. I can do list, and you can see there goes the app, and I could run it. And this was, do you want to go first? Yep, I'll go first. It's not the smartest version of Solitaire. It's generally fairly easy to beat. But you get the general idea. Hey, look, I won. Do I want another game? Oh, I just closed it. And I could go new, and that's cleared out. So if I go list, I've got no program, and I can go print 2 times 3 equals 6, or I could go print hello world. and we'll go and print hello world, or I could go and put in line 10, print hello world, typos, and then I could go run, and voila, complete with the typo. But you get the general idea. So I had a basic, and so you remember the way this is working. I've got my terminal, which is connected over MQTT to a backend MQTT broker, and then those messages are being relayed down to the device on my desktop. And you can see the lights are merrily blinking away, and it's doing its thing. Okay, so what I'm going to do now is, in fact, I'm going to leave the device down the bottom here, and I'm just going to go into what I call CPU monitor mode. I'm just going to have a bit of fun. In fact, what I'm going to do is I'm going to show you how you can use the switches. And we'll just load up CPM. So the first thing I'm going to do is we'll go and bring up the device, and you can see I've got the devices here. So what I'm going to do is, the first thing I'm going to do is I'm going to stop the CPU. And you'll see there's some buttons down the bottom here. You've got stop, you've got run, you've got single step, you've got examine, examine next, deposit next, and deposit. And that was the way in which you programmed it. And what I'm going to do as a really simple demo is I'm going to flick the four top, the high value byte. I'm going to switch those. So the value will be FF00, hex FF00. And then what I'm going to do is an examine. And then what I'm going to do then is a run. And what we'll see on my desktop is you'll see that the device is now booted up into CPM. Now, what that did is when I put in that address FF00, what that was doing is it was telling effectively the CPU to jump to that location in memory. And at that memory location, there is a driver loaded for the disk subsystem. And what's pre-programmed in that disk subsystem is to boot from drive A. And on drive A, we've got CPM. So that's the kind of way this is kind of hanging together. And so we're now on CPM. And it looks, well, it's a bit like DOS for that matter. And I could go and load up BASIC. If I go and load up BASIC, that's loading up BASIC. And again, I can go and print hello world. And I'm off and running with BASIC. And the way to get out of BASIC would be you type in system, of which, by the way, I put in all the manuals I could find on the wiki for this site, for this application. Now, the other things I've got loaded up on here is I had a bit of fun. And in fact, we're just going to look on the B drive. And we'll go into a directory. And on the B drive, I've got a file called hello world. Now, the B drive is actually a read-write drive, and that drive is being hosted up in Azure. And then we've got a Python app that sits up in Azure, and it basically manages the disk sector. So you go and the disk subsystem basically says, I want disk sector number 1. And dutifully, the application will send an application request up to Azure over MQTT, and it will say, I want disk sector 1, and then the Python app will respond back with that sector, which is 137 bytes. So that was kind of how this works. Now, what I'm going to do is, if you're super keen-eyed, you'll spot in there is something called WordMaster. Now, WordMaster was a text editor from the 70s, and when you look at it, you'll realize why it was really is going back. And this was it's a character-based text editor. Now, the important thing about this is that you need to put the web terminal into what's called character mode. In fact, you'll see up here, it says toggle, press Control L to toggle. So Control L. And the reason you do that is now that every time I press like the down arrow, that is sending an MQTT message up to the broker and then back to my screen again. And you can see, so you could go through and edit it, and then you go and press escape and then E to exit. And I'm just going to take that out of line mode. So you'll see I'm out of character mode. So you can see that I'm back in line mode. And line mode is just kind of a more efficient way of working. And then what I could do, I could go CC. So this was going to compile. I go B, hello world, HW, and you can see that's gone and compiled it. and then I could go and do a link, and I go link, and it would be hello world, and it's now linked it. And remember, this is all happening on the Azure Sphere. So this whole, so remember, just to kind of remind what's going on, I've got an Intel 8080 software layer, and on top of that, I'm running binaries of CPM, and on top of that, I'm running binaries for the compilers, the linkers, BASIC, etc. Now, if I go across to the B drive, and if I go and type in hello world, that'll start running, and you press Control C to get out of it. And if I go across back to the A drive, you can see that there you go, I'm just back there again. And if I just go and type, and it was type and B hello world.c, and you can see that's a C application, and wasn't too much surprises. It just sits in a loop. It just counts away. In fact, I just use it mostly for testing. But the main thing about it is you can have a bit of fun with C. It's not quite C as you know it today. It's a few limitations on that, and the manual is up there for that as well. Okay, so the next thing we're going to do is we'll have a bit of fun with assembler. So what I'm going to do is I'm going to cross to the B drive, and I'm going to do arrays star.star. So we'll start from scratch. And by the way, all the CPM commands are you'll find that up there as on the wiki as well. So if I go into a directory, you'll see that there is a file called, and the command is demo.asm. So pip was the way in which you did a copy. I can't remember what it stands for. Basically, it says you say pip and the destination, which is the B drive, and I want to copy across demo.asm. Okay, so what we're going to do now is we're going to load up WordMaster, and we're going to go B drive, and we're going to go demo.asm. Okay, and what that's done, and I'm going to switch across into character mode, and we're just going to jump around here, and this is a bit of assembler. So this is Intel 8080 assembler. And what I'm going to do is I'm going to hit insert and space, and I'm going to type in Dave. And we'll turn insert off, and we'll go escape, and we'll go E to exit, which will say the file. And if I go into type B, and it was demo.asm, you'll see that down here I've modified the file, and it's got hello world Dave. So you can see that on there. Okay, so the next thing I need to go and do is I need to go and assemble that file. So I go ASM, and I go demo. And let's assemble it. So again, just as a reminder, because it can be a little bit confusing as to what's going. Remember, I'm on my web terminal, and this is firing commands down to the Altair, so the application's running on this AVNet Azure Sphere board that's connected up next to me. Alrighty, so I'll just switch back to my desktop. And so I've now assembled it. So the next thing I need to do is do a load. And I go load, B, and it's demo. And that's assembled it, that's linked it. And if I go and look on my B drive, you'll see, in fact, you'll see in here that I've got demo.com. If I go run demo, it will say hello world Dave. Now I'm just going to show you kind of how this works. So if I go and type in so demo.asm. Now the way this works, you'll see that I've got this application's been loaded up at hex 100. And you'll see that the next command, or the next opcode, is going to be a move immediate. We've got load, and we're going to do a call. Now, what these instructions were doing is basically this was the way in which you do a string print. And then this was effectively the opcode, or the opcode, or the CPM API. The value you'd pass in there saying, this is what I want to do. I want to do a print string. And then it would go and call that what was called a BDOS operation. Now, what I'm going to do now is I'm going to press Control M. So what's happened is that I've gone into CPU mode. And CPU mode enables me to actually kind of start playing around in memory in the CPU. Now, of course, there's plenty of opportunities to screw up and break something. But the beauty of this is it doesn't really matter too much. In fact, the way I'm going to do this, now I think about it, is we go, I'm just going to switch across this. I have to do this slightly differently. 1, 2, 3. So I'm basically got like switches here. So I want first 4 switches. We've got 4. I think I want that one. 1, 2, 3, 4, 5, 6, 7, 8. Yep, already. And what I'm going to do is I'm going to do an examine. So what I'm doing is I'm examining address 100 hex. So you'll see at address 100 hex, I've got the move instruction. And if I look up here, there goes my assembler. And there goes my move instruction. Okay, so the next thing I want to do is I want to do an examine next. So I hit the switch down to examine next, and you'll see that the move immediate is a 2-byte instruction. And what that means is that the first instruction, the first value is the opcode, so move, and the next byte is the address, which is 9. And if I go and look up on my assembler, you'll see that there goes 09 hex. And the next thing that I do is I'm going to do an examine next. And you can see that there goes my, I think that was load immediate, I think is what the instruction was, or load register, it might be something like that. And then if I go and do an examine next, you can see the LXI instruction is a 3-byte. So I think that's the high order byte, and then this is the low order byte. And then the next instruction was a return, and that would so the next one is a call. So what that's going to do is call the display, and then the instruction after that is return. So what I'm going to do now is I'm going to do an examine again. So I've still got hex 100 set. So I'm going to do an examine. And in fact, let me just jump back to my desktop. So what was going on here, apologies for my wrong desktop displayed. Just to say, because I didn't have that shown. So I've selected on the switches I had 100 selected, I could do an examine. So I've got a move immediate up here, and just looking at my assembler, there goes my move instruction. It's a 2-byte instruction. Do an examine next. Oops, examine next. You can see I want to do 9 up here, which is the 9 hex value that's been moved into a register. The next instruction was a load. I think it's load register. And you can see those are the high order and low order bytes. And then I'm going to do a call. And there goes the call in the assembler. So the cool thing about this is you can kind of see what is going on inside the CPU. So what I'm going to do now is do an examine. And then the next thing I'm going to do, so what that examine has done is it has set the instruction pointer to hex 100. Okay. And now what I'm going to do, if I switch back to the device, I'm going to switch it back into run mode. So I'm just going to flick that switch down to run, jump back to my desktop, and you'll see what it's done is it kicked off, it started executing that application that was loaded at hex 100, which, as we remember, was my assembler demo called Hello World Dave. Now, what you'll see here is that because I didn't have loaded on the stack the return address, you get kind of an error. You can normally work your way around that just by pressing enter. Anyway, so that's the kind of the idea behind that. Apologies, I constantly managed to forget to flick the wrong screen. So this is the buttons. You can either work it on the screen, or you can, if I jump back to my desktop, you can go into Control M to CPU monitor. I could go and put, I could also go and type in the address here and enter that in. Okay, so that's pretty much how the platform works, and it can be really fun trying to figure out and write applications like this, and it's a really great way of learning a bit more about how CPUs work, how operating systems work, how processors work. Okay, so jumping back over here, so the last bit I want to talk about is while that's all been going on, this is also integrated with IoT Central. Now, if you're not familiar with IoT Central, it's kind of a low-code way of building IoT applications, cloud applications for IoT solutions. And I did that for the Altair project. And I've defined what's called a template. And inside this template, I've got various bits of information about this. So you can see, for example, I was interested in knowing how the efficiency of the disk cache. So you can see I'm getting the disk cache was performing at 300 hits, 320 hits were coming out of the cache, and the cache was missed by 22, which meant that the request had to go up to the cloud to grab the sector from the cloud. And you can see other just general operational information about this. I found it really useful to go and track memory usage of the Azure Sphere, of the Altair emulator running on the Azure Sphere. So this is kind of useful just to make sure that it's kind of behaving as I expect. I can go and change various ways in which the Altair is operating, from sitting on properties and stuff like that. Yeah, and there's also ability to go and do that. So that's the integration with IoT Central. Alrighty, so jumping back to my main screen. So just kind of reiterate how this all hangs together. So remember, I've got the Azure Sphere, and on the Azure Sphere, I'm running the Intel 8080 emulator. On top of that, I'm running binaries for Altair BASIC, which I showed you. We've also got CPM with an operating system that predated DOS. And on CPM, I've got an assembler, I've got a C compiler, and I've got BASIC, and I can go and build apps. And I've also got this virtual disk cache. Now, the thing I love about the virtual disk cache is that it's really applicable to lots of different types of solutions. So, for example, in retail, point of sale, you could use it for keeping price lookup units in a retail scenario. So let's say you had a point of sale solution built on Azure Sphere, and let's say you lost connectivity to your backend systems. The till could keep operating because it would have a local cache of the price lookup units. Those kinds of scenarios where you can kind of deal with that. I've also got another core in here which is doing basic sensor data, looking at the values of. It was looking at temperature, pressure, and humidity was the kind of stuff we were getting back from that. Remember, there's a cloud tier which has got IoT Central, which I just showed you for configuration reporting. I've got an Azure static web app, which I showed you. That is the Altair emulator. So that is a static web app, and that static web app is comprised of HTML and JavaScript and CSS. And I'm using Xterm, which is an open source project, console project, and I'm using MQTT, which is a JavaScript library for MQTT. And you remember, up on the mid-tier, I've also got a virtual machine, and on that virtual machine, I'm running the virtual disk server. So it's a Python app, and it just looks at requests. I want disk sector 1. Okay, here's disk sector 1. And ideally, I'll get that disk sector out of the cache. But ultimately, you always invariably hit the cache at some point. You hit the backend Python server, disk server at some point. And on top of that, I'm running the MQTT broker. Now, if you don't want to set up your own MQTT broker, you can also go and use test.mosquito.org. In fact, that's the default configuration for the project. And you'll see down here, in fact, down in step 22, you'll see that I've got all the documentation, how to go and set up secure MQTT site, how to go and load up the Python disk server, how to go use Let's Encrypt for the encryption between the web terminal and the backend MQTT broker. So anyway, that is pretty much the project. It's a lot of fun, and it will, if you're interested particularly in retro computing, but maybe even more importantly nowadays, if you have a passion around secure IoT, and I suggest we all should have a passion around secure IoT, then please do check out a bit more about what Azure Sphere is. You'll see that there is a link here to the 7 properties of highly secure devices, and that will go into really what Azure Sphere is all about and what we're trying to achieve with this, really around this a world where pretty much everything seems to be under attack at the moment. If it's not ourselves, then it's our IoT devices. And then you'll find all of that there and the overall application architecture. Alrighty, so that's pretty much the end of the session. And if you have any questions, now's a great time to ask. And if you do type those away. And as I said, go check out the IoT Tech Community. So just go search for IoT Tech Community, Internet of Things, Microsoft Tech Community, and go to the Internet of Things blog. Have a scroll down through there. You'll find plenty on Azure Sphere and Azure Percept and things like that. And there goes the project on Altair 8800, and you'll find all the information and the launch point for that. And you'll scroll down through here, and you will also find a link to the GitHub project, and that will take you off over there. So thank you very much for tuning in. Hope you enjoyed that. If you've got any questions or any issues, feel free to ping me on my Twitter. So dglover is my Twitter handle. And if you get involved in the project, then please go and raise any issues on the project. And look forward to kind of engaging with you. And so thank you so much for joining in.
Thank you. Excuse me. Thank you, Dave. Thank you for that. Yes, thank you everybody for joining today. I will share a quick a couple of slides again. Just give me 1 second. And yes, you should see that now, right?
You can.
Yeah, but not this slide. And my computer is really slow right now for some reason. But yes, here, that one. Yes. So yes, thank you everybody for joining us today. The reactor is on Meetup, so you can join one of our pages that is closest to your time zone or region. You can save our website and check our calendar for updates as well. We are always adding more sessions on a regular basis, and you can also sign up for our newsletter, which goes out once a month with sessions that are within your region. And you can also follow us on Twitter, where we highlight some of our sessions. Yeah, thank you all for being here today. You'll be able to rewatch this session in just a couple of days on our YouTube channel, so please follow us there if you haven't done yet. And Dave, thank you so much for holding this session with us today, and I wish you a great evening since you are down in Australia. And I hope I get to host another event with you soon in the future. Thank you once again, and enjoy the rest of your day, everybody. Thank you.
That's great. Thank you so much for joining.
Yes, thank you. Bye.